Thank you, Tierney. Yes, I'm going to be speaking about Node. So welcome, everybody, to NodeConf Europe, and thanks for attending to my talk. I will be talking about new and exciting features in Node.js. A little bit about me. I come all the way from Colombia, South America. It took me a while to get here, but I'm very happy to be in this beautiful place with all of you. I'm head developer advocate at Fusebit, which is a company that does integrations for developers, and I'm a community leader, speaker, Node.js evangelist, blogger, dancer, and even though my last name is Parody, I am not really good at making jokes, unfortunately. And this is my Twitter, Lizz Parody, and Fusebit Twitter. If you want to have any questions or if you want to chat, you can contact me there. So these are the 5 features we're going to see today that you should definitely try. So the first one is Test Runner. Then we're going to see Watch, Stream Accessors, Argument Parsers, and UNDICI. Raise your hand here who has used these 5 features. Yeah, a few of them. Nice. Who has used 3 of them? 1? Cool, most of you. So in this talk, you will have a basic understanding of these features so you can get started and take advantage of them. So the first one is Test Runner. So we can all agree that tests are very important, but before Node.js version 18, there was no third-party, there was not like a test runner out of the box that supported Node.js. So developers needed to use third-party testing frameworks such as Mocha or Jest to do unit testing. But using a third-party framework can add some complexity to do your environment configuration, CI/CD, workflows, and maintainers overhead. And also, it could be challenging which tool to choose because some of those frameworks are like very great to set up very quickly with minimal effort, but they don't have async testing or auto-mocking, or they're not very complete. And there are other frameworks that are the opposite. They have everything. They're very complete. They have async testing, auto-mocking, but they're not as easy to set up. So yeah, it has these trade-offs. So every developer to do tests in Node.js, they needed to install its own test runner. So it just made sense to create its own test runner inside Node.js core. And by doing this, the intention was to enable a limited subset of the functionality provided by most test frameworks in a lightweight manner. So all of you can get started very quickly. You don't have to install anything, and you just add functionality as stop as is needed. So how does this work? In short words, you can do tests in Node.js without any npm packages. You can use the module node test and --test to do some basic searching and matching in test files. It's recommended to do assertion with the module node assert. And just as a fun fact, they took inspirations of building their own test runner by Dino, because Dino has its own test runner. So the people of Node.js were like, well, I guess we can also have our own test runner. Well, I think they didn't exactly say it like that, but kind of. And also, they took inspiration for Happy Lab, for Mocha, and Jest. But in Jest, it actually took inspirations of things not to do in a test runner. For example, injecting global variables automatically and execute code in different... Oops. Hello. Oh, yeah. It's back to normal. And execute code in different contexts because it can have unexpected results and outputs. So I'm going to show you very quickly how the test runner works. So here we have the most basic test. We have test from node test and assert from assert. And we're just saying that NodeConf is a cool conf, and we're just testing that this is true. So if we do, we just see that one test passed and it's all good. And now all of this is inside Node.js, so you don't have to install anything, which is super cool. And for example, if we want to see how it failed, we just see NodeConf is a boring conf, and we just see that it fails. This is the actual and the expected, and yeah, it has some warnings and some trace. So yeah, this is very cool. And you can also skip tests doing this, skip option with messages, and this test will be skipped. And you can also do subtests. So here we're just measuring that 1 is strictly equal to 1 and 2 is strictly equal to 2. And for more advanced functionality, you can do module interception with the modules of proxyquire and smog, spine and stubbing with Xenon, and standalone snapshot with snapshot assertion. And just with everything in Node.js that is still experimental is recommended to not be used in production. And just like at any test runners, promise rejection, error throwing, don't call back, not invoke, they're all treated as failures. And you can use node test as the module and run the test with node and the file name. And also you can do node -- test more options to run multiple files at once. So the second feature is watch. This is super exciting. I really like this one. It's automatically restarting the Node application when it detects file changes. So last year, Node.js tweeted about which single tool have you found to be the most useful in your day-to-day JavaScript authoring experience. And a lot of people replied, NodeMon. It has 5.2 million weekly downloads. So basically, the watch mode will watch the entry point of any required or imported module, so you don't have to stop your server and start again once your file changes. If you just do node -- watch index, your application will automatically refresh just as using NodeMon. And you can use -- watch path to see which path is being observed. Also, this new flag cannot be combined with the flag check, eval, and interactive on the REPL. It just won't work. So that's it. Now you can use node watch index or your file name to start watching your files without having to install anything. But actually, you cannot use it yet. It's going to be ready like in a couple of days. So yeah. Extreme accessors. So it's basically now you can use map, filter, and reduce inside streams. So streams have a reputation of being very hard to work with and even harder to understand. But they are one of the fundamental concepts that powers Node.js applications. They are a data handling method used to read or write input into output sequentially. So they're very good for writing or reading files, for network communications, for any end-to-end information exchange. And what makes a stream unique is that instead of having all the file load into the memory all at once, like in the traditional way, streams are very powerful because they can read chunks of data piece by piece and processing its content without keeping it all into memory. So this makes a stream extremely efficient to work with large data set or a big file. Because, for example, a file size can be larger than your free memory of space. So this makes it impossible for the file to be processed because there is not enough memory. So this is where streams comes to the rescue. By having a small chunks of data, you can be able to work with a big amount of data and big files. So, for example, Netflix or YouTube or other streaming services, what they do is instead of giving you all the content at once, they give you small pieces of data so users can start consuming straight away. So that's why it's called streaming services. But streams are not only good for large files, but they also give you the power of composability in our code. And designing with composability in mind means that you can have different combinations of components and to have the exact same output. So With Node.js, you can create this composability using streams by piping data into another. And you'll be wondering why people should use the streams. Well, mainly for two reasons. One is memory efficiency, and the second one is time efficiency. Memory efficiency because it takes, is more efficient for the memory because you don't have to load all the file into memory at once to start processing it. And time efficiency because it takes significantly less time to start processing a file as soon as you have it, instead of have to have all the payload to process it. And there are 4 types of stream in Node.js. Writable, which are streams that you can write data, and with fs write stream, you can write data into streams. With readable, you can read data from each chunk of streams, and I'm going to show an example. I'm going to actually use the readable streams. And with fs read streams, this is how you can read data from streams and all content and everything. Duplex is both writable and readable. And transform is that you can modify or transform a file that is being written or read. For example, an instance of file compression. You can write compressed data and read decompressed data. But streams has been around for a while, right? But what is new and what is exciting is that now you can use map, filter, and reduce inside of each chunk of a stream. So let's see how this works. So here we have readable, which is one of the 4 types of streams that I just explained from Node streams, and resolver, which help us with the DNS promises. Oh, hold on. And we have a chunk of readable, and we're just reading these 4 numbers, and we're going to map those 4 numbers to be multiplied by 2, and we're just going to console log this. So this is how we read data from streams, and we map it. And resolver, here there's another example. We are reading from these 3 web pages, Node.js, NodeConf, and Fusebit, and we're just going to map those 3 web pages and see the end result and how long it takes. So if you just do node. So this is it. We can see how streams are being mapped and the results of those 3 web pages. And filter is very similar. It's a very similar example. So we're just doing imported readable, resolver, and we have these 4 numbers, and we're going to filter by the number that is bigger than 2, and we just print it out, is 3 and 4. And also here, we're just reading the same 3 web pages, and we filter by like the web page that takes more than 60 milliseconds, and we're just going to print that in the console log. And reduce, we just have readable, and we are having these 4 numbers, 1, 2, 3, 4, and we're just going to do a reduce, like we're going to sum all of these numbers, and if you just do reduce, just see 10. So this is very cool. Before you couldn't do that, but now you can do map, filter, and reduce in streams. Okay, the next one is argument parsers. So now you can parse CLI arguments. So there was a really long discussion inside Node.js of how there were multiple modules that handle parsing of CLI. For example, Commander, JS, and Yarx to create programs inside CLI. And yeah, like the Node.js contributors were like, this is very useful, a lot of people use it, maybe we should have it inside Node Core. Because, for example, Commander had 93 million weekly downloads. Commander just looks after parsing the arguments into options, and command arguments displays usage error for problems and implements the help system. And Yarx, it has 70 million weekly downloads, like just a few weeks that I checked. And it helps you build interactive command line tools by parsing arguments and generating an elegant user interface. So now, with util.parseArg modules, we see that this was merged a few months ago. And as we can see in the description, it adds util.parseArg helper for higher level commands like argument parsing, instead of interacting with process RGV directly. So it takes the expected arguments and returns a structured object with the parse options. So how does the parser work? So it does not execute functions. It does not check for types, not TypeScript, not anything like that. It doesn't allow you to define types, and subcommands cannot take options that are distinct from the main command, so only the main command matters. And -- would signal the end of the options that are parsed into the parser. So let's see how the parser works. So I'm importing parseArg for Node util. And here I just have 4 options. So the name, nationality, dancer, and gamer, and we're just parsing those options and print it in the console log. To see this, we just do node, and then I just do name, Lizz, -- nationality, Colombian, -- dancer. I like to dance, but I am not a gamer, so I'm not going to pass anything there. So if we do this, we can see all is printed here in the CLI. So this is also very cool. And as you can see, this is how if you want to have the exact same output before, you will have to do all of this with processes that are RGV, and yeah, it's more complicated. You have to replace and split, and this can have, it opened the doors for vulnerabilities and bugs, and it's more complex. But now you can see it's way more clean and easy, and you can parse those arguments in a better way. And another cool thing is that the native module is not going to replace the existing packages. Instead, it will empower them to easily catch those CLI arguments and perform complex operations. This was said by Eric Wendell. And finally, UNDICI. UNDICI is a spec-compliant HTTP 1.1 client that is written from scratch and represents the evolution of the Node.js HTTP stack. So I really like the documentation because UNDICI means 11 in Italian, because it's HTTP 1.1 is 11 and UNDICI. And it's also a reference of Stranger Things. So you'll be wondering, why UNDICI? Like, Node.js has already HTTP stack that works very well and is all good, people use it, so why to refresh and create something all the way from scratch? The reality is that the HTTP stack in Node.js have some fundamental design issues that are impossible to resolve without breaking the API. There are certain bugs and performance bottlenecks that will affect the majority of the users, both in the client and in the server. So the team behind UNDICI decided to create a fast, reliable, spec-compliant HTTP client for Node.js. Some important features about UNDICI is that it keeps alive by default, so you don't have to install a keep alive agent. You have LIFO scheduling, which is last in, first out. That is very good for minimizing the time errors, timeout errors. No pipeline by default, but you can configure your own pipeline. It has unlimited connections and can follow redirects and opt-in. So there are important things to understand about UNDICI, like mocking, redirects, and proxy. But because of the length of this talk, I'm just going to talk about mocking. Because UNDICI reinvents HTTP primitives and relies directly on sockets, mocking approaches like knock won't work. But luckily for all of us, Undici comes with its own built-in mocks, so we can test against Undici. So I'm going to do an example with dogs. Let's see how this works. So here we are requiring requests from Undici instead of HTTP. And we're just going to get a breed of dogs that we're going to see this web page that lists all the breeds of dogs. And also we're going to get some images of those dogs. So we get those images, and if there is an error, we just throw the error. So this is the dog client. And the test, we can see this is the test for the dogs. We just hit the first test, we just see that it returns a list of the breeds. And the second test, we just says that we're just looking for the images of the dogs. And then we just catch if there is an error or anything. So we just have 2 tests of the dogs. And finally, Undici mocking. So this is how mocking is made. Mock agent is the basic entry point of the mocking system. So this is how you import it. And then we have intercept that is used to build the mocks. We have the path and the method and the reply. And finally, we just check there is an image path is valid. And we will have the message and some images of the dogs. We check that the image is valid and some to check for errors. And if you just see, oops, hold on. Well, it was working a few moments ago. But this is basically how you do mock in Undici. And because we're talking about pictures with dogs, this is my dog. I found him in a lake. He was very tiny and very little, but now he's very big. He grew up as big as a cow. He's gigantic. And some conclusions about exciting features in Node.js is that first, the contributors in Node.js are always looking to improve the runtime, as we can see with these 5 exciting features that I just presented, but there's other exciting and experimental features that you should check out, like async hooks, diagnostic channels, trace event, web crypto API, WebStrips API, and WASI, that is WebAssembly System Interface. So this is it. Thank you very much, and thank you for the organizers of this conference, and also for the Node.js contributors that are always looking to create and make Node.js better. This is my email, my Twitter, if you want to contact me, and I hope you enjoyed the rest of the conference. Thank you.